Lesson 6.5 is all about the quadratic formula and specifically about the discriminant. Now we'll get to the discriminant later and talk more about what that is. Right now we just want to focus on the quadratic formula and what exactly it is. Now in quadratic equations, when we have them in the form ax squared plus bx plus c equals 0, then we can determine what the value of x is, or our solutions, by plugging them into the equation x equals negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. Now these equations can have one solution or two solutions, and the solutions can be either real or complex. So, whereas before, say we had a couple different parabolas here, if the vertex starts directly at the x-axis, that's when it'll just have that one solution, one real solution. If it went through and hit the x-axis twice, that would be two solutions. And again, those solutions can be either rational or irrational. We might not know exactly where those are at. Or, if it looks like our parabola doesn't ever even touch the x-axis, these still have solutions. That's just when they're complex. So the complex ones, the graph won't actually look like it touches them. So we've learned how to solve by graphing. We've learned how to solve by factoring. We've learned how to solve by using the square root property and completing the square. Now this is our last way of solving quadratic equations, by using the quadratic formula. I'm going to show you a couple examples of how this works. So in this example, we have x squared minus 8x equals 33, and we need to use the quadratic formula to solve for it. Well, first thing we want to notice is that it's not in the form ax squared plus bx plus c equals 0. We want to get that equal to 0. So we have to subtract 33 from both sides. So we get x squared minus 8x minus 33 equals 0. Now it is in our standard form for quadratics, and now we can use the quadratic formula. In this case, we look at it, we see our a is 1, our b is negative 8, and our c is negative 33. And remember, our quadratic formula says that x equals negative b plus or minus the square root of b squared minus 4ac. So the square root is over all that part. Everything is divided by 2a. So we just plug everything in here. X equals negative b. So if our b is negative 8, negative b is just going to be positive 8 plus or minus the square root of b squared. So negative 8 squared, negative 8 times negative 8 is positive 64, minus 4 times a, which is 1, times c, which is negative 33. So the square root goes over all of that part. All of that is over 2 times the value of a. So there's kind of a lot going on these. In this case, we simplify what we've got, so it's x equals 8 plus or minus square root of 64 minus 4 times 1 times negative 33. You're going to want to have these ones written down in your calculator, or not written down, well, you're going to want to have a calculator available. That's going to help out on these ones. In this case, it's going to come out to negative 132. All over 2 times 1 is 2. Moving from here, I'm actually going to move over to this side now. X equals then 8 plus or minus the square root of 64 minus a negative is the same as saying plus. So 64 plus 132 would be the square root of 196 all over 2. In which case, we can simplify that more to say x equals 8 plus or minus square root of 196 is, whoops, I don't need the square root sign anymore, 14 all over 2. Now, in one case, we would say x equals 8 plus 14 over 2. And 8 plus 14 would be 22 over 2. Or if we did 8 minus 14, that would be negative 6 over 2. Then from here, simplify those down, we'd say x equals 11 or negative 3. Because 22 over 2 is 11. Negative 6 divided by 2 is negative 3. So this is our final answer. These are solutions to our given quadratic equation from up there. We got them by just basically plugging them directly into our quadratic formula. So in that case, we got two different solutions. In this case, we're going to see what happens when we get, how we can get one solution out of this. This time, it's already given to us as our a plus b, or ax squared plus bx plus c equals 0. So we can go right into solving with the quadratic formula by plugging these numbers in directly. So x equals negative b. If b is negative 34, negative 34 would be just positive 34 plus or minus square root of b squared. 34 squared would be 1156. Again, this is where having those calculators is going to come in very, very handy. Oops, it should be minus 4 times a, which is 1, times c, which is 289. All of that over 2 times the value of a. So this is going to give us our two solutions of x, or what would be normally our two solutions of x. So we simplify this down into x equals 34 plus or minus square root of 1156 minus 4 times 1 is 4 times 289 is 1156. Again, useful to have a calculator here. Still over 2 times 1 is just 2. Now from here, simplify it down even more to say x equals 34 plus or minus the square root of, well, 1156 minus 1156 is just 0. So plus or minus square root of 0, still over 2. Well, either way in this case, 34 plus the square root of 0, square root of 0 is just 0, so we'd be left with x equals 34 over 2, or 34 minus square root of 0, which is 0. 34 minus 0 is still 34 over 2. So since it's the same thing, we don't need both. We just need the 1. But we do want to simplify that to 17. So in this case, we only have one solution. X is 17. And how we got that was our this number here, this square root, became 0. So that indicates that there was just one solution because we only we didn't change our numerator at all. Because when we added 0 or subtracted 0, it didn't change. So in this case, we just got the one solution of x is 17. Sometimes we might have irrational solutions or irrational roots. Now again, this one is already given to us as ax squared plus bx plus c equals 0. So we can go right into solving by the quadratic formula. X equals negative b, so negative 6 is 6 plus or minus the square root of b squared, so 6 or negative 6 squared be positive 36 minus 4 times our value of a, which is 1, times our value of c, which is 2. All of that over 2 times our value of a, which is 1. So we simplify this down some. We get x equals 6 plus or minus the square root of 36 minus 4 times 1 times 2 is 8. all over 2 times 1 is 2. Come over here then. X equals 6 plus or minus the square root of 36 minus 8 is going to be 28 all over 2 still. In some cases, you might be able to leave this finished because we wouldn't be able to reduce it any. So you could leave it as 6 plus or minus the square root of 28 over 2. In this case, though, we know that the square root of 28, we can break that down into square root of 4 times the square root of 7, because 4 times 7 is 28, and the square root of 4 equals 2. So square root of 28 is the same as saying 2 square roots of 7. So we will want to reduce this one to, or should I say simplify this one to 6 plus or minus 2 square roots of 7 all over 2. From here, we can simplify it more. Notice how our 6 and our 2 square roots of 7 both have a 2. So we can divide each of those by that 2. We'd say x equals 3 plus or minus square root of 7. Now if you wanted to leave it this way, that's okay. Or you could say x equals 3 plus the square root of 7, or x equals 3 minus the square root of 7. Either way you prefer. If you want to write it all out with 2 actual solutions, that's okay. Or if you just want to use the plus or minus, that's totally fine as well. Either way, this one shows us that there are 2 solutions and that they are irrational. They have that square root of 7 in them. We're going to do one more example here. In this case, we have complex roots. So again, first thing to notice is that it is not in ax squared plus bx plus c equals 0. So we need to get it there by subtracting 6x from both sides. So we have x squared minus 6x plus 13 equals 0. Now we are in our standard quadratic form, and we can work from here. Looks like our a value is just 1, b is negative 6, and c is positive 13. So we say that x equals negative b is 6 plus or minus square root of b squared. So negative 6 times negative 6 is 36, minus 4 times the value of a, which is 1, times the value of c, which is 13. All of that over 2 times the value of a, which is 1. So that'll give us our solutions. Simplify that down, we'd say x equals 6 plus or minus square root of 36 minus 4 times 1 is just 4 times 13 is going to be 52 all over 2 times 1 is 2. Simplifying that one down some, we get x equals 6 plus or minus square root of 36 minus 52 is actually going to come out to negative 16 all over 2 still. Now from here, we notice that our radical part here, our square root of negative 16, we need to change that into a complex, into a form of I. So I'm actually going to do that down here. If we have square root of negative 16, we can break that into square root of negative 1 and square root of 16. Square root of negative 1 is just I. Square root of 16 is 4, so this is the same as saying 4 times I. So we now have x equals 6 plus or minus 4 times I over 2. And again, we need to simplify that down. We can divide both of these by 2. So we'd say in the end x equals 3 plus or minus 2i. Or we could say x equals 3 plus 2i, or x equals 3 minus 2i. Either form, either way you say it, is correct. So these are our two complex solutions to that quadratic.